Hi everyone, this is Video 11 on probability. This topic is based on dice. As we all know, in rolling a dice, the total number of possible outcomes equals to 6. 6 represents the 6 different surfaces bearing numbers from 1, 2, 3, 4, 5, 6, and the power 1 represents the number of dice. In rolling 2 dice once, or 1 dice rolled 2 times, the total number of possible outcomes will be 36. 6 represents the 6 surfaces bearing the numbers 1, 2, 3, 4, 5 and 6, and the power 2 represents the number of dice. Let's see the sample space, the different 36 possible outcomes. 1 1, 1 2, 1 3, 1 4, 1 5, 1 6, 2 1, 2 2, 2 3, 2 4, 2 5, 2 6, 3 1, 3 2, 3 3, 3 4, 3 5, 3 6 and so on. Let us discuss example 1. Here, in a single throw of a dice, find the probability of getting a number greater than 4, a prime number, and so on. Here clearly the total number of possible outcomes equals to 6 and the sample space has been given on the bracket. The probability of the event is given by the formula number of favorable outcomes by total number of possible outcomes. Number 1, the probability of getting a number greater than 4. As we all know, the numbers which are greater than 4 are 5 and 6. So there are 2 such numbers. So the probability is 2 by 6, which is equals to 1 by 3. Next, the probability of getting a prime number. Let's identify the prime numbers. 2, 3 and 5. So there are 3 such numbers. So the probability of getting a prime number is 3 by 6, which is 1 by 2. Next, the probability of getting a number less than or equal to 3. Let's identify the numbers less than 3, 2 and 1. As it mentions equal to 3, so we have to include even 3. So there are 3 such numbers and the probability is half. Next, probability of getting a number greater than 6. Let's look at the sample space. I don't see a number here which is greater than 6. So this is the case of an impossible event. So thereby the probability of the event is 0 by 6, which is equals to 0. Next, the probability of getting a number less than 7. As we can all see, the sample space comprises of numbers which are all less than 7. So there are 6 such numbers. Thereby the probability is 1, which is a sheer event. Next, the probability of getting a number which is a multiple of 2. From the sample space, the multiples of 2 are 2, 4 and 6. So we have 3 such numbers and the probability is half. Next, probability of getting a number which is both the multiples of 2 and 3. Let's identify the multiples of 2 and 3. The multiples of 2 are 2, 4, 6. And that of 3 are 3 and 6. 6 appears twice, so count it as once. So altogether we have 4 such numbers. 4 by 6. Next, probability of getting a number which is a multiple of both 2 and 3. Concentrate the conjunction n. 2 and 3. So the number should be both the multiples of 2 and 3. Let's identify the multiples of 2 first. 2, 4, 6. And the multiples of 3 are 3, 6. Here clearly 6 represents the intersection. So 6 is both the multiples of 2 and 3. So thereby we have one such number. So the probability is 1 by 6. Next, probability of getting a number which is a multiple of both 2 or 3. Let's check the multiples of 2 or 3 from the sample space. The multiples of 2 are 2, 4, 6, and that of 3 are 3 and 6. So here altogether we have 4 such numbers. Thereby the probability is 4 by 6, which is equals to 2 by 3. Example 2. 2 dice are simultaneously thrown. That is, 2 dice are rolled once. Find the probability of the following events as given below. Here the total number of possible outcomes equals to 36, and the sample space is given below. So the probability of an event is given by number of favorable outcomes by the total number of possible outcomes. First part, the probability of getting a doublet. Let's identify the doublet. Here doublet means same number appearing on both the dice. So they are 1 1, 2 2, 3 3, 4 4, 5 5, 6 6, and we have 6 such numbers. So the probability is 6 by 36, which is equals to 1 by 6. Next, the probability of getting a sum of 7. Let's go back to the sample space and identify the sum as 7. 1 plus 6 gives us 7. 2 plus 5 gives us 7. 3 plus 4 is 7. 4 plus 3 is 7. 5 plus 2 is 7, and 6 plus 1 is 7. So we have 6 such favorable outcomes. So the probability is 6 by 36, which is equals to 1 by 6. Next, the probability of getting a sum greater than 9. So from the sample space, the sum greater than 9. 5 plus 5, 10, 5 plus 6, 11, 6 plus 6, 12, 6 plus 5, 11, 4 plus 6 equals 10. So thereby we have 5 favorable outcomes. So thereby the probability is 5 by 36. Next, the probability of getting a prime number on each dice. So from the sample space, 2 2, both are primes. 2 3, both are primes. 2 5, 3 2, 3 3, 3 5, 5 2, 5 5, 5 3. So altogether we have 9 such numbers. So the probability is 1 by 4. Next, the probability of getting a sum as a multiple of both 2 or 3. 1 plus 1 equals to 2, which is a multiple of 2. 1 plus 2 equals to 3, which is a multiple of 3. 1 plus 3 equals to 4, which is a multiple of 2, and so on. 1 5, 2 1, 2 2, 2 4, 2 6, 3 1, 3 3, 3 5, 3 6, 4 2, 4 4, 4 5, 4 6, 5 1, 5 3, 5 4, 5 5, 6 2, 6 3, 6 4, and 6 6. So altogether we have 24 of them. Thereby the probability is 2 by 3. The probability of getting a sum as a perfect square. As we know, the perfect squares are 1, 4, 9, 16, 25, and so on. So let's get the sum, which are the perfect squares. 1 plus 3 equals to 4, 2 plus 2 equals to 4, 3 plus 1 equals to 4, 3 plus 6 equals to 9, 4 plus 5 equals to 9, 5 plus 4 equals to 9, 6 plus 3 equals to 9. So altogether we have 1, 2, 3, 4, 5, 6, 7. So the probability is 7 by 36. Thank you guys.